Okay, so taking a look at our next identity that we have to prove. So these look very similar to each other. The only difference is that on this side we have sines, but this side we have the secant. So because we have that secant, this left side is going to be more complicated. Okay, so guys, those Pythagorean identities, so secant squared with tangent squared and sine squared and cosine squared, those three Pythagorean identities, if you ever see a trig function with a squared and a 1, more than likely you're going to use one of those Pythagorean identities. So, if you remember, we know that tangent squared x plus 1 is secant squared x. Okay, so because I have this secant squared and I have this minus 1, I want to turn this Pythagorean identity to figure out what this is equal to. So I just need to move over the 1. So this shows us that secant squared x minus 1 is tangent squared x. So I can rewrite the numerator as tangent squared theta. And then I'm going to keep sine theta. Okay, so we know we want to write it in terms of sine and cosine. So we know tangent is sine over cosine, but I'm going to have to do sine squared theta over cosine squared theta. And then we have sine theta on the bottom. Because we have a fraction divided by a fraction, we're going to do same change flip. So same, change it to multiplication and flip it. Okay, so since I have the sine squared theta in the numerator and the sine theta in the denominator, I can cancel out the squared and just cancel out the sine. So I'm left with sine theta over cosine squared theta. Okay, so take a look. Always keep looking back at the other side of your equal sign that you're trying to show it's equivalent to. So we have the sine theta on top. It's just the denominator that's different. But cosine squared theta, isn't that equal to 1 minus sine squared theta? Let's look at why. So we know that cosine squared x plus sine squared x is equal to 1. Our main Pythagorean identity. If we rewrite this, see how cosine squared x is equal to 1 minus sine squared x? Well, that's what we have here. So this is the same thing as sine theta over 1 minus sine squared theta, which is what we were showing that it was equivalent to on the other side of our equal sign. Okay? And then for our last problem here. Okay, so for this problem, they look similar, they both have the division. So we are just going to be looking at our trig function. So the secant and the tangent are more complicated on the left here, so we're going to pick the left. Now guys, it's not always going to be the left, even though it has been for what we did today. A lot of times it is the left side, but it will not always be the left side. Okay, so don't just always think, oh, it's always the left side. Okay, so we're going to rewrite these. These do not have it's not secant squared plus 1, so you can't use the Pythagorean identities. So we're just going to have to use, we know secant is 1 over cosine x plus 1. And then I know tangent is sine x over cosine x. Okay, so just working with this numerator first, I need to add these two fractions. So if I make this into a fraction, the denominator is missing cosine x. I'm going to put cosine on bottom and top. So this would be 1 plus cosine x. And then the same denominator they have is cosine x. And then we still have sine x over cosine x in the denominator. So because I have a fraction divided by a fraction, I'm going to do same change flip. So keep the top on the same, change it to division, change it to multiplication, and then flip. So because we have cosine x in the numerator and denominator, those can cancel. So we're left with 1 plus cosine x over sine x. Okay? So take a look. This is what we have. This is what we're trying to get. Sine x over 1 minus cosine x. So those look very similar to each other except for they're flipped, and it's 1 plus cosine x instead of 1 minus cosine x. So we had a problem like this on the third problem we did. Remember I told you can multiply by the conjugate, and then that will take care of it. So because this is 1 plus cosine x, I'm going to multiply by 1 minus cosine x in the numerator and the denominator. Alright, so when you multiply 1 plus cosine x times 1 minus cosine x, because those are conjugates, it will give you 1 minus cosine squared x. And then in the denominator, I'm not going to multiply those out. Alright, put that over here. So then, thinking about our Pythagorean identities, we know cosine squared x plus sine squared x equals 1. So I could rewrite this. So 1 minus cosine squared x is the same thing as sine squared x. Keeping the denominator the same. Alright, so look, this is what happens. We can cancel out the sine squared x and just make it sine x in the numerator. And then the denominator we have 1 minus cosine x. So, that is exactly what we needed this to be. So we have finished with this trig identity. So guys, a couple things. This unit is probably the hardest unit, and it's definitely hard with us not being at school. So don't stress a whole lot about, like, if you're not understanding everything. Just make sure you can go from my step to step and understand why I'm doing each step, where the formulas are coming from, like what identities that I'm using. That's the most important thing, is that you're understanding the flow of these problems. If you're at the point where I wouldn't even know where to start, that's okay. Okay, it's okay to feel like that. This is the most complicated unit that we will do. Luckily, if you're taking calculus next year, we use some of this, but we're not really proving a lot of these. So if you know the major concepts, you'll be okay. So just work through the problems, look at the step by step, and just make sure you understand why we're doing different steps.